Hi, I'm Anya, and my project is the self-driving car, along with some image recognition and the car being able to follow certain objects like a person. So, since my second milestone, I've been continuing to work with my Raspberry Pi, the PiCam, and also YOLO, which is the image detection algorithm, and I worked to set up the YOLO algorithm along with the PiCam. So, YOLO actually has a couple preset objects that it can recognize, like books, a phone, or a person, and I decided that I was going to use this functionality of recognizing the person in my project. I played around with a couple extra things as well to make the object detection as efficient as possible, such as dropping the resolution in order to get higher FPS, using the NCNN format, and making the model version a little higher. However, when I ran into a couple errors later on when the camera preview wouldn't open, I decided to revert back to version 8 and didn't use NCNN anymore just to rule out any possible errors. So this is a demo of YOLO and how it works. So it's recognizing me as a person. There is a teddy bear in the background that it can recognize also. There are some books in the background that it recognizes. So it has these pre-built functions. So now I'm showing the camera a pencil, and it's recognizing it as a toothbrush or a baseball bat, and on the frame next to the words baseball bat, the number that it currently says is 0.31, which is the confidence rating, which is really low because it's thinking that it's not very confident that this is a baseball bat or a toothbrush because it actually isn't. So this can have errors and be wrong sometimes. Then I wrote some code saying that when YOLO detected a person in the image, it would find the center of that image containing the person using a couple of mathematical equations. Then it would see if the person is above or to the sides of that center of the image, and then certain pins on the Raspberry Pi would be triggered to tell certain corresponding pins on the Arduino to make the car go forward, left, or right in order to follow the person based on where they are in the image frame. So this is how my car is connected. So this is the Raspberry Pi, this is the PiCam connected to the Raspberry Pi, and this is my car. So as you can see, 3 pins on the Raspberry Pi, they have wires connecting to 3 pins on the Arduino. And so if a certain pin on the Raspberry Pi is triggered to be high, then the corresponding pin on the Arduino, the code will tell it that if this certain pin is triggered on the Arduino to be high, then I will now go forward or left or right, depending on which pin it actually is. Unfortunately, I do have a couple errors in this process, and the car doesn't fully function in order to follow a person. For example, the camera preview on VNC Viewer doesn't actually open sometimes and keeps crashing, so I can't see the actual image detections. I can only see the code in terminal saying 1 person detected or no detection, stuff like that. So this might be because my code is very straightforward and it's easy for humans to understand, which is what happened when I wrote it, but it's kind of intense for the computer to actually complete. So what I need to do is some software optimization in this code to ensure that the camera can actually function and not keep crashing because of how intense the code actually is. Also, the car just moves backwards right now, no matter where the person actually is in the frame, so I need to see what voltage values are coming out of the Raspberry Pi, and if they're doing what they're supposed to do, if they're triggering the Arduino pins correctly to have the car move. So it's really dependent on what is happening when the actual voltage values are sent out, because the code seems to be fine so far. At Bluestamp, I learned so much about different engineering topics and working hands-on for these projects. I learned how to use a breadboard and circuitry and how that all worked, how to use and code an Arduino for my car, and also how to use a Raspberry Pi with a PiCam along with AI software in order to do image recognition, which I thought was a super cool modification that I'm really glad I did. I think my biggest triumph would be writing the code for the Raspberry Pi to detect the frame containing a person and then tell the Arduino what to do and how to move the car. So this code still may have flaws because the car isn't doing exactly what it should, but I was super proud that I was able to write it in Python, debug it, and then combine the best ideas from different projects and their codes in order to have it work for my project and what I want my car and the Raspberry Pi to be doing. In the future, I will definitely be continuing to work with my self-driving car and trying to have the Raspberry Pi correctly send information to the Arduino to have the car follow a person. I think that this project has so much potential, from the code I've written to the hardware I've assembled on the car itself, and I want to see all that I can achieve with this. I've also learned so much about patience and troubleshooting through this process and finding new resources to help me out, which can definitely apply in any new engineering projects that I will try to accomplish in the future. Blue STEM was an amazing opportunity for me, and I'm so glad that I was able to participate in this. Thank you.